Welcome to Wild Turkey Science, a podcast made possible by Turkeys for Tomorrow. I'm Dr. Marcus Lashley, Professor of Wildlife Ecology at the University of Florida.
And I'm Dr. Will Goolsby, Professor of Wildlife Ecology and Management at Auburn University. We're both lifelong hunters and devoted scientists who are passionate about hunting, managing, and researching wild turkeys.
In this podcast, we'll explore turkey research, speak to the experts in the field, and address the difficult questions related to wild turkey ecology and management.
Our goal
is to serve as your connection to wild turkey science. Well, this one ought to be fun.
Yeah, I think so.
You know, we kind of, I guess it was a good time to do it. You know, folks are a little less focused on turkeys, although there are some who have stayed true to the path,
right,
so to speak. But, you know, we've had a series of episodes that are a little less focused on turkeys and more focused on things that are just really interesting that certainly could have been relevant to turkeys. But,
yeah.
You know,
I don't think we ever planned it this way, but it does seem like, you know, this is our second time entering the holiday season on this podcast, and I feel like we kind of just take some liberties with that time of the year and just pursue a few things that fascinate us. As we know that, you know, as the new year comes online, that we're going to be shifting back towards more hardcore turkey science stuff.
Yeah.
So we take this time, I think, to do things that are just a little bit more fringe, but maybe fascinating at the same time.
Yeah, and to me, like the topic today, we're going to talk about passenger pigeons because of popular demand. We've had a number of requests to do that.
Mm-hmm.
But I want people to remember that this is important historical context.
Sure.
And I don't think a lot of people really, you know, we're now 2 generations or 3 removed from passenger pigeons.
Right.
But it kind of paints a picture of how the landscape has changed and how much that can affect the way that, you know, that things are operating. And I'm not viewing it from the perspective of you know, it being sad or something like that. I'm viewing it as, you know, things have changed, they're still changing, and that doesn't mean we can't still meet objectives.
Yeah. I think this is one more paper, and you said it well, I think this is one more paper that that fits in with a general theme that we've carried throughout many episodes, which is that things have changed profoundly in the ecosystems that we manage turkeys in. So this almost fits into that bin of those early episodes that we did on how has habitat changed over time.
Yeah.
And hopefully we still have a few people that listen to those episodes, but we may not.
We're zooming out now with this one. Like this is how it changed a couple hundred years ago.
That's right.
So
yeah. But maybe we should revisit those episodes, I was thinking, because they were so early on when we started the show. It was almost 2 years ago that we covered that topic, talking about, you know, why you would expect turkeys to decline given all the habitat changes that have occurred over recent decades.
Yeah.
But like you said, we focused only on about the past 30, maybe 40 years in those.
Right.
And this goes back even further than that.
Yeah, and I thought it was a super fascinating episode when we recently talked about the American chestnut.
Right.
And that was another one where we zoomed out and think about how much the system has changed. You know, and it was really cool to talk to her about all of the efforts to try to restore American chestnut and all the challenges with that. And, you know, that I think we even got a couple of comments. We definitely got a rating that kind of indicated that it was discouraging. You know, we weren't as close to solving that problem,
right?
You know, as people had hoped, and I can understand that point of view. But
yeah,
It's also really cool that we have people that are dedicating their lives to trying to make sure that something's restored that they never experienced so that they can never experience it.
Yeah.
It's like the next generation would be best case scenario.
Right.
So that's kind of cool, but this is another one of those topics where we're zooming out, and I think it will be equally compelling to the American chestnut story.
Yeah.
In terms of how things changed.
Well, I think too is the more that you understand the history of where we came from and how we got to be where we are now, the more effective manager you can be.
Yeah.
Because you know what has been lost in terms of well, to use a term I don't think I've ever used on this podcast, ecosystem function. You know, what ecosystem function has been lost, and that might tell us something about the management activities, particularly habitat management activities that we need to implement in order to try to replicate as close as we can some of those processes that have been lost.
Mm-hmm.
Because turkeys, you know, like it or not, evolved alongside, you know, the American chestnut and the topic of today's conversation, the passenger pigeon.
Yeah.
So they were adapted.
Indeed.
They were adapted to the facets that those two species brought to the ecosystem.
Yeah.
There's probably a better way to phrase that, but I think I conveyed my point nonetheless.
Well, I did see a little bit of a nervous tick. It kind of jerked a little bit when you said ecosystem function.
That's just this pinched. Hey, that's just this pinched nerve in my neck. Every now and then I'll shrug my shoulders and it just fires off.
I wasn't sure of the cause. I thought maybe it was the Kool-Aid coffee again. I don't know.
No, I upped my game today with some ice water. So.
Hey, no. Yeah. Cleansing. Yeah, and I do want to take a moment to note that we're going to cover one paper. It was Ellsworth and McComb, 2003, I think. This has been out a while. To me, we're going to link this in the notes, and I would encourage folks to go and read this. If you're fascinated with this history and where the data is coming from, and this was a review on this topic.
And how the land may have looked historically.
Yes. Man, it's just like such a phenomenal read, and we're trying to make sure this is available to everybody.
Yeah.
And I would definitely encourage you, if you're going to be sitting on the deer stand over the holidays or whatever, and you need some interesting reading, to check this out.
Right.
It's a really, really, really cool paper.
It is.
So, this paper, I first got familiar with it because I was teaching a basic wildlife ecology course.
Mm-hmm.
And I thought it would be a really fun topic for discussion.
Yeah.
And that's the way I had the course structured is, I would provide the students with some resources to go and engage and think about, and then I'd give them some sort of prompt for a discussion topic that was based on that stuff that they had read about. And for this one, I prompted them to think about why the passenger pigeon was so important to a lot of the legislation in the United States and the North American model of wildlife management, why hunting has been so critical for conservation because of the excise taxes on hunting goods through the Pittman-Robertson Act. All those things. This was sort of an event that, I guess, a stark event in the lives of people at that time that caused a lot of action and really
catalyst.
Yes, it was a catalyst. That's a great way to put it for a lot of what makes the North American model really special and successful from wildlife conservation. And it should hit home for people that love turkeys, because turkeys were one of the species, like they were on the brink of extinction, and they were locally extinct from a lot of their range.
Sure.
And this event stimulated a lot of the legislation and effort that ultimately saved the species from extinction, and also funded a lot of the effort to restore it and conserve it, as well as a whole bunch of other species.
Yeah. That's interesting because I never really thought about passenger pigeons in that way. I've always thought of them in the past as like, a driver of potential disturbance and things like that.
Yeah. Well, I think it's really good for us to reflect on it because it was a really important thing that happened that led to where we are now, and led us to a really, especially in the global context, a successful model of conservation.
Yeah.
And the hunting license sales, the excise taxes through the Pittman-Robertson Act have been
benefited
critical.
all of us as hunters.
Yeah, and we also have key bits of legislation that restrict market hunting and the sale of wild game, and we could go on and on. There's all this early 1900s, mid 1900s legislation, and I think it's reasonable to link a lot of that to this passenger pigeon. So let me give you some context for why I think that personally, and I'm sure we're going to have some critics that are going to DM me and tell me how I'm wrong or whatever, and that's fine. But I think this is some interesting insight. In the early 1800s, there were estimated to be billions of passenger pigeons.
Right.
By 1900, there were no passenger pigeons.
Yeah.
So we went from potentially the most abundant bird on the planet to non-existence. I think the last one that says in here somewhere, the last one died in captivity and it was named. I forgot what it was named, but I think it was 1913.
Martha.
Is that it?
I remember that. Yeah. I didn't just read it. I think it was Martha. And I think Martha is now stuffed in the Smithsonian.
Yeah. So to think about that for a minute. When Europeans were settling, we were viewing wildlife as an inexhaustible resource. There was all kinds of market hunting and exploitation. It's even been dubbed that from the wildlife ecology historians as the era of exploitation. And this was like that wake-up call where people, when they were kids, the sun would get blackened out by passenger pigeon flocks.
Yeah.
And by the time they were elderly, they were extinct.
Mm-hmm. Right. It's wild to think about that in one lifetime.
Yeah. And, that to me is what really had that had to have had a huge effect on people. It's also the primary source of protein for a lot of people.
Oh, I didn't even think about that.
Yeah, like they were eating passenger pigeons. They were stealing eggs, from the massive roost or colonial nest things. That was a really important food source for people.
Well, now you start adding things like that together, and you can understand why people were able to live subsistence lifestyles in Eastern North America for as long as they were. And I think
chestnuts and pigeons, buddy.
Well, yeah, I mean, I don't. So we just released that recent episode, which was you already referenced with it on the American chestnut, and I don't remember if we got into it on that episode or not. But one particular paper that I read is kind of some prep work for that episode, suggested that the loss of the American chestnut was partially, if not primarily, responsible for the loss of the subsistence lifestyle by humans in southern Appalachia.
Mm-hmm.
Which is kind of crazy to think about.
We kind of mentioned, I think I asked a question or said something just to make it a point to point out that it was a really important food source, and then she said something about chestnuts on an open fire.
Yeah.
And then I think you brought that up, that you had found some information about that. And I think passenger pigeon probably would fit in there too.
Mm-hmm. Yeah.
So, I wanted to talk about that for a minute, that this obviously was tragic, or however you want to put it. It's sad to see a species that was so abundant go away, but it also catalyzed action that ultimately has led to a lot of good,
Right.
from a conservation standpoint. So,
Well, where do you want to begin? You want to talk a little bit about their life history, or did you have something else in mind?
we could start there.
I have a question right off the bat. So, what is it about? I have some ideas, but it makes better conversation when I ask you if questions to prompt and see if my ideas are correct
Well,
or not. But
maybe you should feed me a question to ask you then.
well, what is it about their life history that made it so easy for people to drive them extinct?
Well, I think that's partially a
To
loaded
drive
question.
them, let me rephrase that, because that was to drive them to extinction. How about that?
Well, there are some interesting things ecologically, and I don't have there's a couple of good papers that I don't have at my fingertips that I have looked at in the past.
Mm-hmm.
Uh, I can probably find them really quickly so that we can link them so that people
Mm-hmm.
can go see it, but I'm not going to say it on there. It will be linked.
Yeah.
Uh, so let's think about the way that this species operates.
Mm-hmm.
Okay, just from a basic biology, they were colonial in terms of where they roost, where they nest, and think about, we have this massive number of individuals often where they're this huge flock,
Yep.
and they are moving around on the landscape. And think about, there are a couple of things that happens with that. One, when you have high densities like that, it's density dependent factors start to become really important,
Mm-hmm.
like disease,
Yeah.
one that's in particular.
Yeah.
And we often see with species like this that have similar life history, these really big fluctuations in their populations over time
Mm-hmm.
that sort of operate in that density dependent fashion, but the distance between the ups and the downs are really exaggerated.
Mm.
So they may have been fluctuating just naturally over the
Okay.
course of a couple of decades by an order of magnitude or something, where they may have had, a couple of billion on the low end and 15 or 20 billion on the upper end,
Mm-hmm.
just as natural part of their fluctuation.
Right. And I would expect that they really didn't have many predator defenses because they traveled around in such large numbers.
I think
And
that's one, there's safety in numbers.
sure.
So that's probably one of the positive density dependent parts of it.
Right.
There's also, with their biology, there are lots of we don't talk about this much, so I want to make a point of it. There are many things about their biology that are positive density dependent. They actually achieve a greater reproduction and survival because of, or being in, as you increase the
Mm-hmm.
numbers in the group, they increase the success in
Yeah.
multiple vital rates. I guess is
Okay.
a really direct way to put it.
Okay. And when we talk about their ultimate extinction, we generally talk about that through the context of hunting, right? Market hunting. And I'm
That's
sure,
one thing that is commonly talked about.
well, that's what I
But
was going to follow up with was that approximate or an ultimate cause? And ultimately, were there changes to the landscape that put them at a disadvantage? And then you had like market hunting as an additive source of mortality on top of that.
yes,
Yeah.
so this is what I'm trying to set up is exactly what you're saying.
Am I stealing
So
your thunder?
No, not
Okay.
at all. So imagine this species that just naturally, in a stable population that just operates normally, you have these huge ups and downs,
Mm-hmm.
right? And then you add in things like the fact that one of their major food sources were acorns.
Mm-hmm.
And we also have these ups and downs with those,
Mm-hmm.
right?
Mm-hmm.
So that's playing a factor in here. And then we had this rapid expansion of exploitation, we'll say,
Yes.
from European settlement where
Yeah.
we were catching them at their colonial roosts, they had these. We'll put an image in if Charlotte can find it. I think they're called punt guns, or what are they called? You know what I'm talking about?
A
Like
punt
the huge
gun is
shot.
yeah, that's a
The
punt gun.
huge, the huge shotgun that you shoot up into the sky, and they collect them that way.
Yeah, like a zero gauge shotgun.
Yeah, getting. I always think of TK and Mike, where they had that giant shotgun.
Yeah,
You remember that when you were a kid?
Yeah.
About half our audience has no idea what that reference is.
Well, it wasn't just shooting either; it was trapping.
Yeah, they were trapping them. They were getting eggs from the nest. And they were also people whose living was following the flocks around. They're really easy to track when there's a billion of them.
Right. Yeah.
Right. So it wasn't like they were just tracking them all over the country. And there's references to that where that was their livelihood. They were tracking them. And there was also a feather market. They were a delicacy from a cuisine standpoint. The animal itself and the eggs were widely used. So lots of different sources of commodity, I guess, from the animal for humans. And we also were changing the forest structure because we were cutting timber and all that. There were lots of things that were changing at the same time. So the population probably would not have, I should say it a different way. The population probably would have withstood a lot of that pressure had it not been for some of those biological traits that cause those really strong ups and downs.
Okay.
And that's what this one paper that we will link kind of alluded to at the end, and determined that it was really that stochasticity in the population hitting that perfect storm with having these unstable environmental influences on top of the human exploitation that sort of made this perfect storm where when they started going down, they just went through the bottom.
What's interesting about this is this sounds very similar to conversations that we've had about wild turkeys.
Yeah.
Because you think about, we've talked for a lot of reasons why their populations are cyclical and independent of anything that we do. And then if, you have that compounded where you have several years of those factors decreasing populations, and then you layer on top of that habitat loss or increased predator context or any, wild pigs competing for resources or all of the above, and you catch them in that down cycle, and it's almost like compounded.
Yeah. I think that's right. And some of that, let's imagine with the passenger pigeon, because it's such an extreme example of this, but they're potentially naturally going to go from, let's say, 15 billion individuals to 3 billion over a 10 or 15 year period, because that's the way their population cycles.
Mm-hmm.
And then you add in that they have several factors, especially reproduction and survival, that tend to be positive density dependent. Because a lot of our colonial species like this, or species that live in really large flocks, they tend to be less productive and have lower survival in the low because they're facilitating each other's success. And then you combine that in with the exploitation, from various life stages.
Right.
And you can see why it would be really difficult for it to recover.
Absolutely.
Once it starts going down and it gets to that low, it doesn't rebound, which it probably would have when you had really good weather and really good mass crops and
good habitat.
Yeah. Lots of the predators are satiated from other things or switching to an alternative source. You got in the ecology of the system, it could have corrected under those circumstances, but adding us into it. In this case, it was so extreme that those population fluxes, that probably is what made them vulnerable, according to some of this research anyway. I should have gone back and read that again so that I'd be prepared to talk more explicitly about it. I didn't know if we would get into it and I did not, but we will link it.
Well, I'm
so
always
people
good
can
for
read.
that. I'm always good for getting you off topic.
Yeah. So let's talk about some of the ecological things.
Yeah, that's what
So
I think people are going to be really interested in.
yeah, so fascinating. And again, I would love for people to go and read this. And if you have questions about it, we're happy to talk to you about it. Just reach out. I guess we didn't talk about where passenger pigeons were. You want to talk? Let's talk about that real quick.
Yeah.
Essentially, they were all through the central hardwoods and Appalachian region. They went up well into Canada with the normal range. The nesting area was largely in the Midwest to the Northeast.
Yep.
So that's where a lot of the nesting was going. But the normal range that they occurred within is going well up into Canada, all the way down through about central Texas eastward to the eastern seaboard, and that would include Panhandle and North Florida.
Yeah, so it's basically like east of the Great Plains in the U.S. Yeah.
Basically, the tree line,
right.
essentially.
Yep.
And that makes sense, that might be the case. But I didn't realize how wide ranging they were. I guess that was interesting.
I had never really thought about it till you showed me this paper. I knew they were here. I didn't really think about where else they were. But given that their life history is so dependent on forests, it makes sense that they would be primarily confined to the eastern United States.
Yeah. So another thing that just occurred to me, when we were talking about getting nests, a lot of the people at that time were also concentrated where the nesting is.
Sure.
Concentrated.
Yeah. Mm-hmm.
That's interesting. So, shall we get to some ecology?
We shall.
Okay. So, I want to walk you through this because they did this in the paper, and I found it so fascinating. Well, to give you context, in their feeding habits, they did eat a lot of fruit and insects, earthworms, buds off of trees, but when it was available, they ate mast, especially from beech, oaks, and American chestnut.
Mm-hmm.
Isn't that something? Kind of connecting some dots here. So there was a paper that estimated that pigeon colonies would have been able to search an area between 80 and 160 kilometer radius from their roosts or nests.
Wow.
So how many is that? 40 to 80 miles or something? That's pretty good ways. That's just from where they roosted last night.
Yeah. Let's see. Yeah, about 50 miles at the low end.
I don't know how they figured this out, but this dude Shorger did back in the day. He quantified that each pigeon would eat about 0.07 liters of food per day. I don't know what that doesn't mean anything to me unless we put it into context.
0.07 liters.
Yeah, 0.07 liters. So if you estimated a total population of 3 billion pigeons, they would have consumed 210 million liters per day in that flock.
How many?
210 million liters per day.
210 million liters a day?
Yeah.
All right.
We got to put that in context.
I'm going to make that relevant for you.
Please do.
That is the total volume of 84 Olympic-sized swimming pools.
Okay, so they ate 84 pools of data. 84 pools of food a day.
So that's a Olympic-sized swimming pool is like 50 yards long and 25 yards wide, I think. And you imagine 8 of those, and they're about 6 feet deep. And you imagine 8 of those
a day. That's pretty good. Acorns were making up a portion of their diet during breeding. Let's see. There's an average. Okay, this is kind of switching gears a little bit. There's an average of 80 to 370 viable red oaks acorns per liter. That's based on Olson from 1974. Healy observed that an unthinned second growth red oak stand produces about 30,000 to 155,000 acorns per hectare per year. So based on
that's 2.5
the median figure,
that's 2.5 acres.
Yeah. We estimate, and this is coming from this paper, the oak stands probably produced between 133 and 689 liters per hectare. Okay.
Lots of numbers flying around right now.
Well, I just find I think it's fun to go through the math, right?
It is.
I'm not expecting anybody to remember any of this. In fact, I already can't remember it, but it's going to be put in context for us. Which
all I remember is 84 swimming pools.
Yeah, there you go. See, that's why you put it in context. That's what you remember. The entire passenger pigeon population at 3 billion could have consumed the total red oak acorn production from roughly, on the upper end, 1.5 million hectares of red oak forest per day.
1.5 million hectares?
That's a tenth of Alabama a day.
A tenth of Alabama worth of red oak forest acorn production.
Yes, per day.
Wow. That's profound. I feel like I've been using that word too much. But
well, I mean, when you just keep uncovering stuff that's profound, what are you going to say?
I've got a follow-up question for you on that one, Marcus.
Yeah.
Do you think they would have been capable of eating all the kern on the landscape?
Man, we'd have had to pour it to them, buddy.
And how many days would that take?
Good Lord. I mean, need we say anything else? Think about how, in 10 days, they could have ate all the acorns produced in Alabama if it was all red oak dominated forest.
Yeah. I mean, so think about the implications of that for turkeys. I mean,
yes.
We're worried about pigs, and how many acorns they consume, but this is like orders of magnitude greater than what pigs ever consumed.
Oh, yeah, it's not even close. They were just sucking it up like vacuums.
Did they eat chestnuts too?
Yes.
Yeah. Chestnuts were probably key to supporting their populations, I would guess.
I think that, it should have smoothed out that population fluctuation because, at least you'd have more consistent food.
Mm-hmm.
So, and I'm not a historian. I'm reading what other historians have written about.
Sure.
And, it's hard to, know what was going on back then. Even think about if you tried to put together what was happening right now, 100 years from now, based on what you find on social media or in the news or whatever.
Right. Yeah. So back to the acorn consumption.
Yeah.
They consumed, if I'm recalling correctly from the article, they consumed so many acorns that their preferences may have driven differences in oak regeneration.
Yes. That's one of the arguments they make here. Let me see how they worded it.
If I remember correctly, they said that their consumption of red oak acorns would have favored white oaks rise to prominence.
That is exactly what they're saying. I'll read this sentence to you when I find the beginning of it. They propose that consumption of vast quantities of acorns by pigeons during the spring breeding season may partially explain the dominance of white oak through much of the pre-settlement north-central hardwoods region.
Yeah.
And the extinction of the pigeons probably facilitated the increase in expansion of red oaks, and especially northern red oak.
Mm, that's so interesting. But that in that regard, I guess you could think, oh, we're just speculating here and just kind of trying to tie it
Yeah,
back
but
into
it's
turkeys
fun.
to keep it interesting for the audience. But so they were a competitor for acorns, and their foraging habits favored white oak over red oak. So two negatives for turkeys potentially. There's some positive ways they affected turkeys as well, which we'll get into, I'm
Yeah,
sure, in just a second.
there's
Um,
probably some net gains here.
yeah,
Uh,
but their extinction may have resulted in the increase in prevalence of red oaks, which are more favored by turkeys, as we just established in a recent episode.
Indeed.
All right.
So, are you suggesting the reason we had so many turkeys it's because of the passenger pigeon? I think they're probably a good reason why we still have turkeys,
Yeah.
because of what we talked about earlier. But yeah, it's hard to know, exactly how they would have interacted and affected things. But I wanted to, I thought it was fun to go through that, but that's not even close to all of the effects that they had. I mean,
Well, let's keep going down with some of the down the list of some of the more major ones.
another effect that they definitely had, and you could relate to this. Let's take 1 billion pigeons and put them all in a colony together. What do you think is going to happen to the woods where they decide to roost?
I mean, they're going to tear them up.
Yes, they
That's a
they they
that's a
broke them
technical
down.
ecological term. They're going to tear them up.
Yeah. So they estimated this. They said from our estimates of the amount of land used annually for nesting, the disturbances would have caused or would have occurred frequently, so at least every 12 to 13 years across the area, affecting about 8% of the breeding area annually from these forest disturbances. And they were specifically talking about the physical damage of sitting in the canopy.
Yeah.
So
Did
they
you?
got like this low intensity disturbance of the canopy that's increasing sunlight penetration
Yeah.
over, about a 10-year interval that's happening, if because they're moving around.
Right. There was that one section that I really wanted to read. And if you're on it right now, go ahead and mention it. But it was where they were talking about how they stacked on top of each other's backs and the number of them per square meter.
Oh man, it's so gnarly.
Do you have that? Do you have that
They're
handy right now?
literally sitting on top of each other
Yeah, they're roosting on each
on a
other's
limb.
back.
That's what I want turkeys to do. I want there to be so many turkeys that they're sitting on top of each other on the limb.
There it is. Here it is. Here's the sentence I was looking for.
Yes.
With observers citing every centimeter of medium to large tree branches occupied by roosting pigeons, with some roosting on the backs of others, they estimated that there were 10 pigeons per square meter, which is about a square yard of ground, or approximately 105,000 pigeons for every 2.5 acres.
100,000 pigeons per 2.5 acres.
Yeah.
50,000 pigeons per acre. That
And,
is.
and so just the mass.
They did the math on this. Are you calculating how much mass of pigeon there is?
Yeah, they did the math, but I'm just trying to convert it.
Double check them.
I got to convert it into freedom units.
Oh, okay. Freedom units.
So they came up with 140,000 pounds of pigeons for every 2.5 acres. 140,000 pounds for every 2.5 acres.
That's pretty cool.
We're going to have some more fun with these conversions here. So,
Do you have more?
well, I'm going to make it relatable. That's the equivalent of the weight of 28 F-150s.
Per 2.5 acres?
For every 2.5 acres, 28 F-150s.
How many Chevys is that? Good grief, man. You know, that's shocking. So is the acorns. They're eating all the acorns every 10 days in Alabama. If it was all, I mean, that's nuts, you know.
Yeah, but we need
that was a pun I didn't even mean there. But that isn't even what has resonated with me the most. The thing that I have said to people in this, you know, I'm talking about this in the class often, and this really gets people excited about ecology. It's really great for students in my experience. But those kinds of numbers are shocking, but they didn't really put it into context for me like this other thing does. You know what those pigeons are doing when they're sitting on top of each other? Yes. They're shitting everywhere. All over each other, you know?
On each other's backs, apparently.
In the long-term roost sites, Schorger and Blockstein and Tordolf and Wilson all have referenced this. In the long-term roost sites, there was so much dung that it was that was literally killing the vegetation in thousands of hectares at a time.
Wow.
The estimates.
So we don't even have to worry about the branch breaking. It's basically like pouring out bags of fertilizer all over the woods.
On the long-term roost site. So you have to think about, these are at different temporal scales. They were migrating around, and then they'd have some places that they commonly are at, right? So you've got different levels of disturbance at different scales.
Yeah.
So that's a mosaic of disturbance or heterogeneity being caused by it's kind of eye-opening to me to think about it, like how dynamic that disturbance was but in some of the roosts that were reused annually, the dung deposits exceeded 50 centimeters in depth.
Wow.
That's feet.
Yeah. Yeah.
There's feet of poo ubiquitously distributed across the woods.
Talk about being neck deep in shit.
It was literally to an extent where the long-term roost could not be that long-term because it killed all the trees to roost in.
So they were creating canopy gaps.
Yes.
Not only through breaking the branches, but also through their excrement because there was just so much of it.
Well, the breaking the branches, that's like a really low intensity disturbance. You know, it's increasing sunlight penetration all through the woods everywhere they go.
Yeah.
But this is a long-term effect that probably promoted things like, I don't know, the chestnut.
Mm. So how would it do that? How would it promote the chestnut?
Because they're a shade-intolerant, disturbance-dependent species.
Yeah.
They would have.
So I wonder how that worked out on the long-term sites though, where they had those feet, you know, excrement that were several feet deep. How does anything ever revegetate that site?
I don't know, man.
Or presumably, would they eventually abandon that site and then it would naturally revegetate and they'd move on to a new one?
Yeah, I mean they're basically moving around.
Yeah.
So
I don't know.
It's just wild to think about.
That's something that maybe we don't talk about enough, though, is those natural disturbance processes, because we recommend to people all the time to log, right, for turkeys in various ways and means. And so the reason that we have to do that now is because a lot of these natural processes that historically would have taken care of that disturbance for us are gone. So we still have windstorms, obviously, but we don't have things like, or we don't allow things like beavers, right, to flood forest, and that would be a disturbance process. We contain wildfires as best as we're possible, you know, as best we can. Passenger pigeons are gone. So there's all these disturbance mechanisms that historically would have maintained these habitat conditions that we're looking for oftentimes for turkeys across the landscape. And so we're just trying to replicate those now.
Yeah.
And we're trying to do it on our piece of dirt too, right? Like that's the other critical component is this stuff historically would have just happened somewhat stochastically, randomly across the landscape, but we want that certain habitat condition on our property now. So we use, somewhat artificialized methods of creating that and maintaining it.
Yep. I think a lot of the things that we talk about from a management standpoint, they're on and their ecological basis are mimicking things like this.
Processes that have been lost.
Yeah.
That have
And
affected
it makes a lot
the
of
functioning
sense.
of the ecosystem.
Right. It makes a lot of sense why doing those would benefit a lot of the species that are still present.
Right.
And it also makes sense why a lot of our disturbance-dependent species are the ones that are of concern.
Right.
Right. Like you can just keep layering it on, like apparently they did with dung. But that one to me really
layering it on with dung.
It shakes me up every time I go back to it. It's like, dang it, man.
Yeah.
That killing 1,000 acres with poo.
Uh-huh.
I got my parenting instincts to say poo now. So the other thing is, it's not like all these disturbances operate in isolation of one another.
Sure.
They also talked about the pigeon flocks were interacting with other disturbances.
Such as?
They suspect, that's what they wrote, that the disturbances by pigeons probably exacerbated the effects of wildfire.
Yeah, I remember reading that. So they're basically contributing, like slash, right? Like almost like logging debris to the understory when they break these branches and limbs.
Well, and you think about it, if we went in and killed all the vegetation, like apparently these roost sites might have done, you killed all the vegetation, the trees and the understory plants and everything, what's going to recolonize that first?
Annuals. Annuals are going to come back, yeah.
Yeah, and we have a pretty predictable successional trajectory that's pretty flammable.
Yeah. You also have to wonder about their role as seed dispersers, too.
Oh, yeah.
I knew you would like that one. Are you so proud of me? Are you so proud of me for getting into that?
Yeah. Go on and pat yourself on the back. Well, it is kind of interesting because they were eating a ton of seeds, and a lot of those seeds need to be scarified through the digestive tract, and they do better when they are deposited in dung in terms of germinating, and a lot of them also need full sun or at least partial sun to do well.
Yeah.
So you could see where that could have really driven the successional trajectory.
And bigger picture too, think about how, I don't know if this article even touched on it, but think about how they changed the nutrient cycling in an area.
They do talk about it in here.
Did they?
I don't recall exactly.
Well, I mean, they were even affecting aquatic ecosystems. They had to be,
Oh, yeah.
in these areas where they would roost, and then I think we've gobbled enough this episode, but you know what runs downhill.
Oh, man. Well, that's right. And, just to reiterate so it potentially was making the landscape more flammable and facilitating wildfires, and they cited a bunch of
It was opening the canopy.
Yeah, and I mean, think about that. I talk about it. I say this all the time. In these closed canopy, especially hardwood systems, that system is light limited. And then I follow that with saying, prescribed burning, you're not going to realize the benefits of the fire unless you reduce the canopy so that light is not limiting.
Yeah, otherwise you're just burning leaf litter.
Right. Because light still suppresses the things that would have been stimulated by the fire. And you think about that in this context, like now we've got a disturbance agent to increase fire, potentially removing species that are not flammable, replacing them with more flammable species, and then the fire is stimulating, a suite of desirable species because light isn't limiting either.
Yeah, so if even if you consider the food resource competition, I think because of those factors, they were probably a net benefit to a species like turkeys that, requires that landscape heterogeneity. They require
Yeah,
those areas that are later successional where they roost and where they feed during the fall and the winter time, and then they
yeah,
require those earlier succession areas that they use during the breeding season.
right. And I think when we recently talked with Zach Danks from Kentucky, he was kind of talking about the interspersion of different vegetation structure and vegetation
Yeah,
types. And
yeah,
I mean, that's kind of what I would envision based on this to emerge because of this passenger pigeon moving around and having different levels of intensity coupled with interactions with fire.
it almost makes me wonder if could they have been the most important disturbance mechanism on the landscape at that time.
They certainly made an argument in here that I think is fairly compelling that one of the most important types of disturbance in terms of releasing sunlight to the ground was the pigeons.
Even more so than wildfire or wind events or anything like that.
I think well they talked about the wind events that would cause uh, forest disturbance at the same scale would have been like 1 in 100 year event or something.
Oh, yeah, good point. To the extent that they did, yeah.
Yeah, so that's why I'm really encouraging people to go read this paper. It is fairly long. It takes a while to read it, and obviously we can't remember everything in it. But I do remember reading about that specific thing. They were trying to put the disturbance in context with the other ones, but they also wanted to make sure that we put into context that they're not operating in isolation. It's probably the disturbances interacting to shape the overall function of the system.
Yeah.
I mean, think about like what if you went out and thinned the woods and burned and then poured 10 tons of fertilizer on it, probably gonna get a different thing,
Yeah.
right? Like there are lots of things going on here that probably changed the way the system responded to
Well,
that
just think
disturbance.
about, I mean, there had to be predators that either use them for a portion of their diet or maybe even specialized in them at that time.
Yeah, there definitely were. There's one hawk species they talked about in here that's thought to have specialized on them
Mm-hmm.
that is now rare, I think, in that particular instance, and there may have been one that went extinct. There's several beetle species. We were talking about dung beetles. They probably were in hog heaven with this, right? There are some that were thought to have specialized specifically on passenger pigeon
Yeah.
that are no longer present.
Yeah. Makes
There
sense.
are some that are rare that are carrion beetles.
Uh-huh.
So that just means they eat dead animals.
Yeah.
But they specifically specialized on passenger pigeon carcasses. Because it turns out when you got billions of them flying around everywhere and they're sitting on top of each other and dropping the elbow on each other or whatever they were doing, a lot of them die. Right?
Inevitably.
They die from all kinds of reasons. So there's probably carcasses laying around, and there were beetle species specifically focused on that one carcass type.
Yeah. Could you imagine just watching like a Cooper's hawk or like a peregrine falcon or something like that just working over a flock of passenger pigeons?
I just want to look at its eyes, like when it's kind of flying around looking for something to eat, and then it sees the sky turn black with food.
Yeah.
It just kind of lights up.
Yeah.
Yeah. It really is interesting to read back through, and it puts it into context for me. Like, man, the system has changed a lot. That doesn't mean we can't still meet objectives, but it starts to make sense how some of the things that we're doing are needed, or are missing and are needed because of that. When you start to think about some of these historical disturbance contexts.
I think it's high level, but I think it's also at the same time important sometimes to take a step back and take stock of why we implement the forest management and habitat management um, actions that we do, because there's sometimes concern from various groups, or the general public, about why do you need to cut trees, or why do you need to burn the woods and things like that. And if you have the ability now to explain how ecological processes and ecosystem function has been lost over time due to extinctions like of the passenger pigeons and of the American chestnut and so forth and so on, I think when you can make that connection for people, you end up gaining more support.
Yeah.
And it's not necessarily that person is then going to go out and help you burn to increase turkey populations, but they may be there to provide feedback in the city council meeting when the local city council is talking about municipal laws related to burning and smoke management and things like that affect your ability to carry out the habitat management that you need to for turkeys.
Yeah. May, garner support and reduce barriers
Sure.
to a lot of these actions, and reduce the turmoil in the community among people that have different viewpoints, that sort of thing. Yeah, I mean, when you look at, they kind of have a conclusion section where they were trying to, put together this whole thing on what this means. And I think you nailed it. It really puts into context, that based on the stuff that they uncovered, the passenger pigeons caused disturbances at
they were intense and they were at a large scale.
Yeah, and an intensity and frequency, and also variation in that intensity and frequency over space and time,
which is what we try to replicate.
Exactly. It puts into context why we might need to intervene. But that they described it as low intensity crown thinning, which would have released established shade tolerant vegetation, to severe disturbances that would have been stand initiating disturbances. That's like where we had the feet of poo around the thing that killed all the vegetation. That would have caused widespread limb and stem breakage and heavy nutrient loading, characteristic of long-term pigeon roosts. What else did they say?
Yeah, so they're out there creating the whole range of canopy openness. So the whole gradient. So some areas obviously would have remained forest, but then you had everything from a woodland where they stopped overnight and they broke a few branches and they let 30% sunlight through, all the way to an area that you're completely starting over again as bare ground.
Yeah, and I didn't talk about this earlier, but they found evidence that there were extensive migrations, and they generally had a lack of site fidelity. So what that means is there were definitely places that were continually used as roosts, and that'd been those stand initiations, but that was more on the uncommon side.
Yeah.
It was probably more of this really light forest disturbance and, nutrient input that would have, broken the canopy and allowed sunlight in, but not necessarily stand initiation, but they were mixed in.
Yeah.
And that tells a lot.
Yeah.
They also wanted to make a point about how much it influenced the oak species composition.
Yes.
First, the roosts created mid-size. This I'm reading directly from their paper. The roosts created mid-size and large canopy gaps in the canopy that may have favored moderately shade-tolerant tree species. Makes sense why we have a bottleneck on oak regeneration, why we might prescribe something like the shelter wood technique to favor those moderately shade-tolerant tree species. They also caused fuel accumulation by killing, plant material that would have likely led to intense and frequent fires, and favored other oak species like white oak, bur oak, black oak, that are more fire resistant. And the consumption of acorns also probably shifted favor even to the species that weren't targeted by passenger pigeons. So, it's like a bunch of things were all going into that to lead them to believe that it was affecting which trees were dominant on the landscape, and particularly favoring more shade intolerant species that are also more paraphytic.
Yeah. Yeah. Those are all good points. And there was one other that occurred to me while you were going through that, and it was that I feel like oftentimes we get caught up in having the idea that the Southeast was where the disturbance, dependent ecosystems have always lived.
Yeah.
But their perennial roost sites, that's not the sites that they stopped over at, but the ones that they used traditionally year over year that would have had an even higher level of disturbance were kind of around the Northeast.
Mm-hmm.
And then they had, obviously, their population was centered on Appalachia as well. And so these are areas that a lot of us get stuck in the mindset of considering to be later successional dominated
Yeah.
regions of the country.
Yeah,
But in
they're
fact,
isolated from the fire and wind disturbances.
in fact, some of the disturbance activities of the pigeon were centered on those areas.
Mm-hmm.
I mean, that
And
roost
probably facilitated the other disturbances.
absolutely, and
Yeah.
like, I mean, in particular, their primary roosting area included New York and Pennsylvania and several other states up there. So, I mean, there was disturbance there too to the canopy and the understory.
Makes a lot of sense. It also makes a lot of sense why thinning and burning, those two things in particular, are really important
Yeah,
for forest management for
Yeah.
a lot of wildlife species.
absolutely.
Well, that was fun.
I definitely enjoyed it, and I hope some folks learned
Yeah.
some things, and not only just from an entertainment perspective, but also from an ecological education perspective
Yeah.
too. And to me, that's what's really, I don't know, I guess the word would be reaffirming, that a lot of times the things that we're recommending are based in sound, I was going to say ecological principles, but more like sound ecological history.
Yeah.
That those processes need to be reinstated because the way they were historically implemented no longer functions for whatever reason. And this is just one example of that.
Yeah. We also have all these non-native species. I mean, there's all kinds of things that
Oh yeah,
make
we
that
haven't
true.
even gone to, yeah. That's the other complicated factor now, is if we disturb it, we may not get the right vegetation back.
Right. Yeah, I agree with you. It definitely. I think we started out with this, and maybe we can end with it. Learning about the history of these systems and how they were functioning with stuff like the passenger pigeon gives you some insight on why they have changed, but also how we should deal with it, like where we should go from here, right? So I think that historical context. I know this episode wasn't focused on turkeys, just like a couple of our other ones haven't been, but I do think it's important context to understand where we were, how systems were being shaped, and then that kind of leads us to why they've changed and where we need to go to deal with it.
Well, you also know that anybody listening to us in November is a hardcore listener anyway.
Yeah. We got some learners on there right now.
But then again, they have to kill time on the deer stand anyway, right?
Yeah, there's at least 3 or 4 of them that can't figure out how to get the podcast to stop playing. Sometimes the app, like when I get in my truck, the podcast app just automatically starts playing stuff, and I can't figure out how to turn it off. They've just given in.
I love the thought that there's somebody out there that has unwillingly listened to every episode.
Every time we launch one, it starts playing automatically. Yeah, I hope not. I hope folks are enjoying it. I guess if they're still sticking with us, they are.
I would hope so.
Or they can't look away at the train wreck.
Anything else?
No, I think we're good. As always, thanks everybody for listening. We really appreciate the support. If you have other topics like this, you obviously will stray away from turkeys. We're trying to stay close, but when we get enough feedback to go after a topic, we'll do it.
Yeah. Yeah, it's hard to stay perfectly on topic with 52 episodes a year,
Yeah.
But we tied this one today back to turkeys pretty well. And Also, for anybody that hasn't been listening for that long, if you haven't already left us a review, please do that. And always, when you leave that review, leave us a comment too, so that we can know what we can do better or what you have questions about. And that also helps us get the word out to more people.
Absolutely. All right.
Thanks, everybody. Wild Turkey Science is part of the Natural Resources University podcast network and is made possible by Turkeys for Tomorrow, a grassroots organization dedicated to the wild turkey. To learn more about TFT, check out turkeysfortomorrow.org.